So this CS1410 class is called Object-Oriented Programming. So it's time that we actually learned about Object-Oriented Programming. So the first half of Section 1, we are going to be learning about Object-Oriented Programming. We're going to identify potential objects and their member variables and functions. We're going to be able to create classes and create class objects. We're going to be able to access those class objects. And then we're going to be able to differentiate between what is a class and what is an object, and between access specifiers. Finally, I'm going to introduce you to some special utility functions, and then we're going to learn that we can separate the definitions and the declarations into separate files. So what we have been doing so far in this class is when I give you a requirement for a program, you go through it and you identify all the objects, all of the variables that you're probably going to need, and then what kind of functions are you going to need in order to manipulate those variables in order to execute the program correctly. Well, back in the late 1980s, we started to take a different view of a software program or a software system. And somebody said, maybe instead of trying to define or identify all the variables and then the functions that are going to manipulate on those variables, maybe we should look at a software system from the point of the objects that make it up. For our purposes, we're going to use the object, think of a noun, a person, place, thing, or a transaction. For instance, if I were to tell you that I wanted you to write a software system for a university, your brain might start thinking of the nouns that make up the university system: students, teachers, courses, buildings. These are all nouns, person, place, things, or transactions within a university. So then we're going to pick out one of those nouns, one of those. Let's start with students, and we're going to find out that for every one of those objects that we have just identified, those nouns or those objects, there's two things, two characteristics. The first one is things that we want to know about it. We're going to call it attributes for a minute. And then things that that object should be able to do. We're going to call that operations for just a minute. So let's look at students. Students within a university system. What kind of things might we want to know about a student within the domain of the software itself? Well, we might want to know their name and address and their GPA and their balance due and some things like that. And what kind of things should a student be able to do within this software system? Well, they should definitely be able to register for classes, drop classes, graduate, and pay parking tickets. So these are some of the things that we want to know about a student object and some of the things that we want to know that a student should be able to do. And from there, what we're going to do is we are going to define the variables and the functions. So the attributes come up to the variables that we're going to be using for this object, a student, and then the operations are going to be called the functions, things that this object should be able to do. So we're going to give the variables data types such as string name, address, and class standing, a double GPA. We're going to define the functions. So you'll notice there is a return value, the function name, and then any parameters that that function might need. And from there, now that we have an object within a system, we have the variables and we have the functions. Now we're able to encapsulate those two things into one single space, a single unit called a class. So a class is made up of variables and it's also made up of functions. This word encapsulation is the concept of wrapping the data and the methods that operate on that data into a single unit called a class. We're going to see that it can restrict access to some of the objects or some of the members of the class, and it can allow access to other members of the class. So here is an example of a teacher class that we have just been building. A teacher is made up of variables and functions. If I wanted a better view of this teacher class, I'm going to use what is called a UML class diagram. UML stands for Unified Modeling Language. It is an industry standard diagram that shows the components or the members of a class. It's broken up into three segments. The first segment is the name of the class. The second segment is the variables, including their data types. And then the third section, or the third segment of a class diagram, are the functions themselves. Now you're going to notice there are full method signatures. That means return values, the name of the function, along with a comma-separated list of parameters if there are some. You're also going to notice that there is an access specifier at the beginning of each one of the class members. The minus sign means that they are private, which means they're only accessible to other members of the class. The plus sign that I can see on the functions means that they are public, which means they're accessible within the class but also accessible outside of the class. And if there was a pound sign, that would mean that it is protected. Protected means that it's accessible within the class and outside the class to inherited class objects. So let's create a class. We're going to use the key name, the keyword class. We're going to give it a name. I'm going to have an opening and closing curly brace, but this time notice there is a semicolon at the end of the curly brace indicating the end of the class. Then I'm going to use the keyword private with a colon, and then I'm going to declare all the members that are private. Here we're declaring all of our variables as private. And then I'm going to use the keyword public followed by a colon, and along with all of the members of the class that should be public. So this looks kind of like a structure, right? We have dealt with a structure before. The difference between a class and a structure is this accessibility. The default accessibility for a structure is public. The default accessibility for a class is private. I'm going to use the keyword private anyway, even though the default is private, because it makes it more explicitly clear. I also want to mention that not all variables have to be private and not all functions have to be public. It's just a matter of what the class needs to be to do. All right, so this is now a better example of our teacher class that we have created. So I use the keyword class. We're going to call it teacher. I have my opening and closing curly braces with that closing semicolon. And then I have the keyword private along with the variables with their data types. I have the keyword public along with the function declarations here. We're just going to do the declarations, which is the full method signature. That means the return value, the name of the class, and any parameters that are required for it. And we're actually going to do the function definitions outside of or below the class to kind of keep the class clean. All right, so how do we go about instantiating objects of the class, also known as creating objects of a class? We are going to instantiate or create an instance of a class. So we'll have an object. Well, we're going to take our teacher class and let's see if we can just instantiate objects. We're just going to use the class name, kind of like the data type, and then the names of the variables. For instance, we're going to create a couple of teacher objects, Peterson and Duhadway, just like I was declaring any other variable. How do we access them? We're going to use the dot access operator. So I'm going to use the object dot and then access to any of the functions that I want. For instance, here I'm in the teacher class. There is a function called pay parking tickets. We're going to use the Peterson object dot pay parking tickets, and I'm going to pass a double to that in order to be able to reduce the balance due. So this is how we instantiate objects of the class and how we use class objects. So the last thing that I'm going to mention here is what is called the state. Every single class object has instance variables. Now Peterson has a name, a pay grade, and a balance due. Duhadway also has a name, a pay grade, and a balance due. They are called instance variables because Peterson and Duhadway most likely will have different values for those instance variables. And the state of an object is the value of their instance variables at any moment in time. I would expect Peterson's balance due to drop or increase if they got a parking ticket. I would expect their pay grade to increase over time. Names might change if they get married or if they just decide to change their name. So the state of an object is the value of its instance variables, like a snapshot of the value in those instance variables at any point in time. All right, so the next thing that we're going to do is how about if we create a vehicle class. We're going to practice with a vehicle class. So here's an example of a class UML diagram for a vehicle. It is going to have 5 variables, 4 strings, and then a double odometer reading. There are going to be 3 functions available to us. All of our variables are going to be private, and all of our functions for our purposes are going to be public. So they can be used outside of the class. So how about if we try that out?